In this video, I'm going to talk about data screening by case and by variable. And for this video, if you want to follow along, you'll need this data set. It's the YouTube SEM series data set on the home page of StatWiki. If it doesn't show up, just hit Control F5 to refresh the browser or the web page, and it should show up if you hit Control F5, not just F5, or not just the refresh button. Okay, so here's what we're going to do. Let's go over to data screening. Oh, not that one. General guidelines, excuse me. And wait for it. There we go. And here are the order of operations. And we need to do case screening and then variable screening. So let's start with our data set. Let's go look at our data set. It's the exact same data set you have. YouTube SEM series.sav. Here it is in the variable view. You can see we have all the independent variables. That's playfulness, comprehensiveness of use. Atypical use, usefulness is a mediator, joy is a mediator, info acquisition, and decision quality are dependent variables. And then we have our controls, gender, age, education, and our two multi-group moderators, frequency and experience, and then an ID variable, just for keeping each record straight. If I go to the data view, here's all the data. What we need to do first is find out if we had any cases, that is rows or people, that did not respond to very much. So let's just, the easiest way to do this actually is to hit Control A, Control C, and do it all in Excel. So let's do that. Control New, Control V. All right, here we are. And you know what I really need is those variable names. Let's go get them. The way to get them is to go back to SPSS, just highlight all of those names, Control C, go back. I should actually insert a row here, and on a different sheet, hit Control V, and then Control, it won't let me do it, let me Control C again, paste it here, Control V, Control T will do this. It's going to transpose it in that order, which is kind of nice. Control C, go back and paste it right here, Control V, and it should go over to the last variable. Yes, okay, we're in. So the first thing we need to do is find out if we have many missing from a single respondent. The best way to do this, I think, is to use the equals is blank. And for the value, just Control Shift left, and it's count blank, excuse me, not is blank. Count blank. Yes. And then let's get the range. There should be 0 blank in the variable row. Let's go here and rename this to blanks. And then I can just sort by blanks. Now, we're allowed to sort because we have an ID that we can refer back to and maintain a consistent order. We can always sort by ID to get back to our original sort order. So let's sort data, sort Z to A, and we see here we have out of our, how many, let's see, out of our 49, you can see here 49 variables, these two guys are missing 47 of them. Are they useful? No, they're completely useless, so I'm just going to delete them. That's justifiable. Now, these guys are missing 2. That's not that many. If it were, like 10% of the variables, so in this case it'd be about 5, then I'd be concerned. But it's only 2, so we'll just impute those values, which I'll show you how to do very soon. Okay, and the rest had nothing missing. Wonderful people, aren't they? Okay, now let's go find, let's go look at our order of operations. We did case screening by missing data. We need to look at unengaged responses. All right. What is an unengaged response? It's someone who responds with the exact same value for every single question. So they put 4s all the way across, or 3s all the way across. There are other things they could have done, like 1, 2, 3, 4, 1, 2, 3, 4. It's harder to detect that without just a visual inspection. So what I'm going to do is I'm going to just type in, not there, I'm going to look at the standard deviation. And we could go like this. Let's see, equals standard deviation, P, sure, of which ones? Well, just the latent variables, probably. There we go. All the way back to the beginning there. And enter. And drag that down. And that is just too many numbers to look at, so decrease the number of decimals. And let's sort again. Okay, where's data? Sort A to Z. And this will show us, look at this, this person has 0 standard deviation. What does that mean? That means they answered 3 for every single question. So are they useful? No, not at all. Get rid of them. That is a justifiable deletion. All right, this person had very little standard deviation of 0.15. So let's go look at the responses. 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. Wow, that's a lot of 4s and a 3. So, are they useful? Not really. I mean, they might have been telling the truth, but they're completely useless because they don't have any variance in their responses. So an increase in, let's say, playfulness isn't going to make any difference when we look at an increase in information quality, because there is no increase. They stay the same. There's no variance. So I'm going to say they're pretty useless. In fact, anything under about 0.5 is probably pretty useless. Let's just go look at a few others just to make sure. Here's a 0.3. 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. Yep, that's a lot of 4s, a couple of 3s. So atypical use, they put 3s. That's a little bit more engaged in the survey. For these ones, I would just do a really quick visual inspection. 3s, 4, 3, 2. Okay, fairly engaged. 4s, 3s, 4s, 5. Hey, somewhat engaged, so we might have to say that's good, except this top one, there was a 0.151. They were completely useless, not engaged at all. So I'm just going to get rid of those. Let's keep these the rest of these. You always want to remove as little data as possible. You want to remove the ones that are clearly unengaged or malicious. Hopefully we don't have any of those. Okay, what do we do next? Let's go look at it. That's unengaged responses. Next is outliers. Okay, so let's put all of this back into SPSS after deleting these 2 rows we just used and after resorting the ID column. Okay, we're back in the original order. We're minus a few. Let's see, how many do we have now? We have 381 responses now. I'm going to copy all of this except the top row. That's Control-Shift-End, and then I'm going to have to hold Shift and press up and left a little bit. There we go, I've got it all. Control-C, go back to SPSS, Data View, delete everything that's there, because we're going to overwrite it. You don't just Control-V or paste over it, you actually delete it all, because now we have fewer responses. And paste. There we go. Scroll down to the bottom, make sure we're clean. Okay, 380, yep, let's scroll all the way to the right, and the ID column is filled, so we're good. Okay, the next thing we said was to look at for outliers. All right, we're using latent variables on a Likert scale of 1 to 5. So is there such thing as an outlier? Not really. There might be somebody who answered differently. You know, everybody answered 5s, but this guy answered 1. Is that really an outlier? Well, we don't know, and so we can't remove him. So no, not really. But we could have outliers on gender. Well, not gender because it's a forced response, so it's only a 1 or a 2. We could have it on age and education, frequency, and experience. Who knows? Maybe there were some real oddballs on each of these. So let's go look at those. Analyze. Let's see, descriptives. Actually, the best way to do this probably is graphs, legacy dialogues, box plot. And just do a simple separated by variables. Is that right? Define. Yeah. And then we want to stick in age, education, frequency, and experience. Label cases by ID. And hit go, or OK. All right. And here we have it. So age. We have somebody who is 35, apparently. Somebody who is 33-ish. Are they outliers? Not in the sense of abnormal, erroneous, bad data. No, it's just somebody who was old who took this survey. Old as in 35, haha. So can we delete them? Well, only if we say that we're only interested in people between the ages of 18 and 25. So I wouldn't delete them. Let's look at the next one. This one is, I can't tell. Let's see, we started with age. The next one's education. Education. Somebody said they had 11 years of education. Wow. That's pretty good. It's number 193. Let's go find out how old number 193 is, just to make sure this person could really have, that many years of education. Here we go, 193. So here's education, 10 years, but they're 22. That means they started college when they were 12. That it could be possible. You got those child prodigies. But if they did, then why are they still in an undergraduate intro course? I'm thinking this is probably a mistake on education, and it would make sense to replace it with the median. I think that's definitely an outlier, an erroneous outlier. So the median in education is hard to tell. Let's see if it gives it here. Nope. Let's go run it. Analyze, descriptives. Let's go get education. And we're just looking for the median, or the mean, fine. Continue. And the mean is 2.18 years. I'll just stick a 2 in there, because that's probably the median, 2 years. And that has changed. All right, let's go to the next one, which was frequency. No outliers on frequency. And then on experience. Holy shnikes, this guy has 25 years of experience? Has Excel even been out for 25 years? Let's go look at number 291. 291. 25 years of experience, and he's 21 years old. Huh. I think that's a mistake. So let's go find out what the median experience is. The mean experience, descriptives, throw education out, look at experience, okay, and the mean is 4.4 years. So I'm just going to stick 4.4 in there. 4.4, okay, and that solves that problem. That was clearly an erroneous outlier. You can't be 21 and have 25 years of experience. Okay. Even if you were using Excel in the womb. All right, so that takes care of outliers. Let's go to the next. And missing data for variable screening. Let's go to missing data. Let's save now. I'm going to go to Analyze, Descriptives, Frequencies, and we're just going to stick everything in there except ID, I suppose. We don't need ID. And we're going to go to Statistics. Looks like we're good here. I think it automatically tells us about missing, so hit OK. And here's the missing table. I'm just going to copy it. It's a fairly big table. Yeah, just copy it, go back over to Excel, stick it in here, and just say, highlight all that and do something like, where's conditional formatting? Oh, bother. Home, conditional formatting, highlight cell rules greater than 0. Okay, now we can see who's got some missing data. Experience, age, decision quality, info quality, or acquisition, excuse me, and joy. Oh, and usefulness. Okay, so what we need to do is replace those values with the median if they're on Likert scales like this, or if we want with the mean for more continuous variables such as age and experience. So let's do that. I'm actually just going to consolidate here so I can see it all. Just see the ones that are missing data. Okay, so usefulness 2, 3, 5. We'll go to here. Transform, replace missing values, and what was it again? Usefulness 2, 3, 4, 5. 2, 3. Did I say 4? I just meant 5. 2, 3, 5. And then joy 6, info ac 3. Joy 6, info ac 3. And decision quality 1. And age and experience. Age and experience. All right, that's a lot. So what do we do with these? We have to do them one at a time. So usefulness, we want to rename it actually just the same thing. We're just going to replace the missing value inside here with the median of nearby points and use all. That's just the median of the whole variable column. And hit change. You can see it changed up here. I'm going to do the same for usefulness. Get rid of that. Give it a median. All change. I'll do this for each one, just a minute. Okay, I've done all the Likert scales. You can see they've all been changed, but I haven't changed these more continuous variables, like age and experience. What I'm going to do for these is instead of median, I'll use mean. So for age, age, do the series mean, change, and for experience, do the series mean, change. And hit OK. Yes, I want to change existing variables. And it tells me how many it replaced. So for usefulness 2, it replaced one value, and now we have 380 for a valid, non-missing values for each of these variables. So we're good. And save. Oh, not the output. Sorry. Nope. Go back to SPSS. Save. Okay. And what's next? Skewness and kurtosis. All right, last thing for variable stuff. Let's go to analyze, descriptives, frequencies, I believe will do it, statistics. We don't really need skewness on a 5-point Likert scale, so I'm just going to do kurtosis, continue, of everything. Yep, that's right. We'll need to see skewness of education and frequency, though, and age. Age isn't in there. Let's see. Age. Oh, it took out all the ones I recalculated, so I'll throw those back in there. In fact, I'll throw it all out so it gets alphabetized. Control A, throw it back in, get rid of ID, and it didn't re-alphabetize. Nice. Oh well. Hit OK, and here we have it. Lots and lots of stuff. Okay. But this is the table I'm looking for. So I'm just going to copy this, Control C, go over to Excel. I love using Excel, by the way. I'm going to just use, instead of the standard error of kurtosis, I'm going to just use the kurtosis value, and anything greater than or less than the absolute value, I guess, of 1. So greater than, anything greater than 1 is candidate for being kurtote. I actually don't like 1 because it's just too close to the border. I'm going to use 2 to show us just the extremely kurtote items. Hit OK, and then conditional formatting one more time, less than -2. OK, and now we'll see the ones that have issues. I'm going to go ahead and get rid of the ones that don't. And Control-Shift-X, and oh, it's just those guys actually. Wow. Okay. So it's just usefulness, info, ac, 1 and 3, and age. Age is highly kurtote. Why? Because we looked at undergrads in a class. And so they're all essentially, 19 to 23 years old. So the distribution is very small and it's very centered around the median. So they're going to be kurtote. Is there anything we can do about that? Nope. So we'll leave it. All right, then you got info acquisition is 2.589. That's pretty high. It's not a 3, but it's pretty high, which means there wasn't a lot of variance on that item. People answered it very similarly. Same with these two. Now, if they were if they were strong negative values, it would mean that everybody answered fairly differently and there wasn't a central tendency towards the median. So what do we do about these? Well, we just watch them. We just make note, these are kind of kurtote, and then look at them in the EFA to see if they cause problems. For example, they might have low communality values or they might not load on any single factor. And that's that, I believe, for screening. Woo!